Hi guys, solving LeetCode 26, remove duplicates from sorted array. It is an easy array question, but it's a bit tricky. Okay, question says, given an integer array norm sorted in non-increasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in norms. Consider the number of unique elements of norms to be k. To get accepted, you need to do the following things. Change the array norm such that the first k element of norms contain the unique element in the order they were presented in norms initially, and the remaining element of norms are not as important as well as the size of norms, and return k. So basically what this question is saying is that you will be given an array, a sorted array. This is a sample. You will be given this sorted array, a sorted array like this. I mean, this array is sorted. We have 0, 1, 2, 3, 4. And you have to, what your function is going to do is it's going to make sure that the first set of elements in your array has to be unique elements. As you can see, our array has duplicates. We have 0 twice, we have 1 3 times, we have 2 twice. So what your function, the algorithm, is supposed to do is that it returns unique elements first. So now we have 2 zeros, so it's supposed to take 1 0 and maybe just push it to the back of the array. We have 3 ones, it's supposed to take 2 out of those 3 ones, push them to the back, and retain just 1. So we have 0 1 2 3 4 uniquely, and then we cannot have those duplicated later. So this is what we are going to have. And then finally, the function is supposed to return the length of unique elements in the array. So we have our first 5 elements will now be 0 1 2 3 4. So that gives us 5 elements. So our output should be 5. But the condition now that makes this really tricky is that you cannot create a new array. You have to modify the existing array. So I can't create another new array because if I could, I'd probably just use a set, but I can't do that. All right. So what we'll do first is to initialize a variable k. Remember, the variable k is what we are returning, which is the number of unique elements. So we initialize variable k as 1. So this is our variable k. Let k equals to 1. Let me put it here as well so we can see it in action. K equals 1. It is only our first element that is unique for now at this point in our algorithm. Let me change the color of the first element to orange. No, come on. So we've initialized our k, and what we're going to use our k to do is that we're going to use it to track the position where the next unique element should be placed, and we're also going to use it to know the length of the unique elements that we have. So currently our k is 1. Let this arrowhead represent our k. So we are looking for an element that would be in position of index 1. So our first element 0, of course, is unique. Let me change the color to orange so that we can know that, oh, this is unique. Now we're looking for an element that will fill this position. We look at the element here currently and we compare it to the previous element. So we loop through. So we start looping through the array starting from the second element, because the first element will always be unique. All right, so we pick the second element, we compare it to the previous element. If it is the same, that means it is a duplicate. But if it is not the same, then it is a unique element, and we should put it at the current position we are looking for. And then whatever was there before, we can push that to the back, right? So in this case, 0 is still the same as 0. So it is not a unique element. So we move on to the next thing. We move on to the next element to check. We are currently checking this element. We want to fill this position. Let's move on to the next element, which is 1. We check 1 and compare it to 0. Is 1 the same as 0? No, 1 is unique. So because 1 is unique, we bring it down to this position. We remove this 0 and we move this 1 to its position. Let's give it a unique. So what we are going to be doing right now is we create a conditional statement. So we are saying that if norms index, that if the current element is not equal to the previous element, then we put it at position k. So, which is exactly what we did here. Remember, we compare 1 to 0 and it was not the same thing. So we move 1 to that position. We took 0 to the back because, excuse you. So norms k will now be equals to norms index. It's a little bit confusing, but that's what we're doing. We are putting that element at the index of k, at index k, right? So Now that we have put that element at index of k, that means we filled position 1. We increase k by 1 so that we move on to the next position. So now we are trying to fill this position. You got me? Let's bring this 0, 1 here. So we are trying to fill this next position. We are trying to fill our position 2. This is position 2. Now let's take that element here. So let's take the element here, this 1. Let's compare it to the previous element 1. They are the same. It's not a duplicate. Let's move on to this next one. Let's compare this one with the previous element. They are also the same. They are not a duplicate. Let's move our comparison to 2 here. Now let's compare 2 to the previous element. 2 is a unique element. So what we are going to do is that we're going to bring 2 to this position. So we bring this 1 down, we bring this 1 down, and we move 2 here to this position and give it a color orange. All right, so we increase our k as well. K we increase and be 3. So now we are looking for the element that will stay at position 3. So let's bring this one for the, sorry. All right, so that's exactly what we are doing in our conditional here. And remember, we are increasing k by 1 for every time we push an element to the position of k. So now currently our k is at 3. We are looking for something that will fill this position, this index 3. All right, so we have 2 currently. Let's compare 2 to the previous element. It's the same 2, so it is not a duplicate. Let's compare 3. 3 is unique. So now let's bring 2 down. Let's move 3 to our position 3. Let me change this to orange and let us increase by k, our k by 1. Our k will increase to 4. So now we are looking for the element that will be at position 4. So we already have index 0, index 1, index 2, index 3. Now we're looking for index 4. Now let's compare the next element. Our next element is 3. Let's compare 3 with 3. It's the same thing. It's not unique. Let's move to the next element. Let's compare 4 with 3. Now 4 is unique. So we bring this 3 down because it is not a unique element. We already have a 3. And we move 4. And we move 4 to position 4. So we no longer have any unique element. If we keep looping, we probably will not have any other unique elements. Again, all of this here will just be pushed to the back of the array. All of these duplicates will be pushed to the back of the array. And what we now have is 0, 1, 2, 3, 4, a set of unique numbers. And the total is 5. Remember, we still increase this one by 1 after we get our unique, after we moved 4. So we have 5 unique numbers, 1, 2, 3, 4, 5. So our function will output 5. So when that is done, we then return k. Is it a bit confusing? I feel like it's so hard to explain this. All right, so let me quickly explain the code. Line 1 here, what we are doing on line 6 is that we are initializing a variable k because the first element will always be unique. So let our variable k start from 1. And then we are looping through the array from the second element to check if the current, so we have a check here to check if the current element is different from the previous element, the element before it. So we check if it is different. If it is different, then we place the current element at position k, and then we increase k to prepare for the next element. That makes sense, right? So after we have looped through each of the elements and we have run this conditional for each of them, then finally we return k. All right, let's try to run this. Let's see what we have. All right, so we have test case 1 was successful and test case 2. Oh, Jesus Christ. All right, make sure your variable k is declared outside your loop so that it don't reset for every element. Okay, so we have this our code. Let's run it. All right, it was accepted for case 1, and we have 1, 1, 2, and our output was 1 and 2, which is correct. And then we have case 2, 0, 0, 1, 1, 1, 2, 2, 3, 3, 4, and our output was 0, 1, 2, 3, 4. That was correct. All right, let's try to submit this. Our submission was accepted here. I'm not sure about this beating 100% part, but yeah, our submission was accepted, and this is our code. Don't forget what we did. We declared a variable k first. We looped through the array starting from the second element, and we were comparing each element to the previous element to check if it is a duplicate or if it was unique. If it's a duplicate, we don't do anything. Our k will stay at position 1. And if it is a unique, we take that element to position 1, and we increase our k by 1 to prepare for the next element, and finally we return our k. I hope you enjoyed this video. Please, if you are interested in tech and coding content, don't forget to comment, don't forget to subscribe, and see you in my next video. Bye.